Let me go ahead and share my screen and we'll get started. So also just wanted to double check. Can you all see the encodio just because I saw some other messages? Do you all have this encodio? Do you have this or something similar in Codio? No. Uh-oh. Okay. Maybe, because that is the first step. Of course, that's important. So you're just seeing the PDF. Okay. Just the PDF. So
Let
worst
me
comes to,
double check
okay.
on the back end and I will get to you.
Okay, great. Thank you so much. So we'll just do an icebreaker in the meantime. We have a little bit of time just because towards the end, we don't have to do everything. We just really need to get you started with NumPy because it's one of the top Python packages. But I would love to hear what you all did over the weekend. All the weekends always feel too short. And yeah, I'm happy to tell you about my journey as well while we're checking. So just while you're telling me about your hopefully lovely weekends, I'm currently a PhD in host microbiome interactions. So I do a lot of with Markov models, with R, with Python, with Excel. So I look at a lot of sequencing data and bacteria and genes. So I'm actually finishing up my PhD and then afterwards I'm going off to medical school. So I absolutely love school, as you can see. And looking at live chat, I see a lot of work and a lot of work study. So I really hope some of you actually got a little bit of rest over the weekend. And let's see. And thank you so much. Thanks for the kind messages as well. I really appreciate it. And I see some questions too. Since I'm in London, did I see the episode of Doctor Who? I did not. I unfortunately gave up Doctor Who a little while ago, so I lean more towards anime, honestly. But I still do think Doctor Who is awesome. But very cool learning more about all of you. And of course, a lot of your TAs are amazing. A lot of them I recognize. So you are all in wonderful hands towards the end of your data analytics journey. Ooh, a concert from Haley. So amazing. Hopefully that concert was fun. So very cool. So with NumPy, I'll tell you, excuse me, a little bit about NumPy as well. And great to see you again as well, Crystal. So you're going to learn Pandas soon, which is my all-time favorite. With pandas, if you have some time, I would recommend you check Seaborn as well, Seaborn and Matplotlib. And you don't have to remember this because I'll put it in the chat at the end. But Seaborn and Matplotlib are what we use to actually do data visualizations very quickly. So pandas, NumPy, Seaborn, and Matplotlib are kind of our core packages that we use in Python for data analysis, and then EDA, of course, can't get away with EDA, and then straight to data visualization. So you can do these visualizations really quickly and understand your overall data story. So that's going to be ideal. And NumPy is going to be all about the numbers. So we're going to learn all about arrays, all about why arrays are a little bit better than lists. And then just doing calculations with these big chunks of data. So as you might know, if you have a lot of totals, if you have bills that you have to calculate, or you're trying to create invoices, you might have different taxes, or you might have different extra costs depending on location. So you don't want to have to do 10 loops over and over again to calculate all of these costs. It's better to do them all in one using these arrays. So that is what we're going to do today. And oh my gosh, getting back into One Piece, so cool. So I'm reading the manga on One Piece, but I'm only on chapter 160, so long way to go, but amazing. So I think what we'll do just in the meantime, I can get you introduced to what you've seen before at the very least until we make sure that you're able to do this. So the things that I really want you to do, I really want you to get used to Jupyter Notebook overall. So what I'll do right now is just explain Jupyter Notebook because I know this is a lot of your first time seeing this, but Jupyter Notebook is a really handy tool in doing data analysis. Because before, I know you were working in your terminal, which I personally do as well because I work usually on a high performance cluster, but it's not the best because you have to retype your code. You only have maybe a few lines of code until it gets really bulky on the terminal. It's not ideal. So this is why we have Jupyter Notebook. And let me get my favorite laser pointer so you can actually see my mouse. So let's just do a quick introduction to this. So we have our beautiful Jupyter Notebook. If you want to actually do data analysis like this yourself, this is what a lot of people in data analytics use. You can download Jupyter Notebook to your computer, and then you can actually access your files. So you can import some of your files into Jupyter Notebook and then do data analysis on them from there. There's also a browser version, which is, I think, in testing right now, but it's more common to have just the Jupyter Notebook. So this is what we're going to use. And Tyrone has an amazing question. So what about using Vim? So yeah, Vim is also a text editor. So just using Vim on Linux is just going to be your text editor. If you wanted to just write Python script there, you absolutely could, and then just run the Python script maybe on your computer. You absolutely could do that. But Vim is a little less user-friendly. Remember, with Vim, you're kind of restricted to your keyboard keys, so your numpad. You have some commands that you're restricted to. It makes it a little bit harder to delete and replace. So overall, it's not as flexible as Jupyter Notebook. But we have this. So let's just go over kind of what these things mean while we're waiting to get set up. So this plus is going to be, as you probably guess, it's going to add something. So when you do this, it's going to add a cell below. It's always going to add something below. Oh, it's there. Woohoo! Thanks, Gladys. I'd love to see that. So if you refresh, we can go over this together, but we're still going to introduce Jupyter Notebook, so that works out perfectly. So this plus is just going to be to add a cell. The individual cells, so you see this rectangle right here, that is going to be where we're running our chunks of code. You see, typically we're going to have just individual lines. So we're going to have single lines of code just for organization. As we go a little bit later through our course or the case, we're going to see bigger chunks of code. So typically you just run one kind of statement at a time within a cell. And this is really just for organization. So I see, okay, so a lot of you, it's still a PDF. So we'll hopefully by the time we go over the Jupyter Notebook, maybe it'll appear for you then. I'm hoping. So this plus is just going to add a cell. And then again, the cells are what we're going to do our analysis in. So, and no need to install Jupyter Notebook. We're just going to use this right in Codio once it's available. But if you want to install it on your own, then you're absolutely welcome to. So now let's just look at navigating the different cells. So when we're running a cell, that means we're executing the function. So just like if you were to type this in your terminal and hit enter, that's the same as running a cell. So just kind of as a throwback a little bit, what does this mean again? What are we doing with this statement? What are we doing with this statement? And the statement also is assuming something. So what are we doing with this statement? I'd love to see the several people typing. I always love to see that. Amazing. Amazing. Yeah, so I know this might be pretty fresh because I think you just went over packages, importing packages. So yes, exactly. We are actually importing the package with this import NumPy. And remember, this is assuming that we've already installed the package with pip. So remember, pip install, insert your favorite package here, is how we install packages into the Python environment. You might notice you might have not seen this as MP before, but if you throw back all the way to SQL, this is just like our alias. So we're telling Python, import NumPy and call it NP. So whenever you see NP, that's going to refer to NumPy. So when you call specific functions, you don't have to type numpy.random or numpy dot any type of function. Instead, we'll do np.random just to save a lot of space. Amazing. Awesome. So to run something as well, you can just press this. So you'll notice once I press this run, so when I press it, you're going to see a number appear. When I press it again, this number is going to increase. So this just means how many times this cell has been run. Okay, I see. So yeah, I'm sorry about that. I'm sorry, it's just the PDF. So I think worst comes to worst, what we might have to do is I'll just go through this with you, and you have to give me every single question, confusion, something that's not clear. You just have to throw them all at me so I can go through this in as much detail as possible so you can do it yourselves once it's available. That's the worst case scenario. So just going back to the cell, this number is going to represent how many times you've run the particular cell. If you see a star here, which I'm hoping eventually you might see, but I don't think you'll see it in the case when you do this later, that means it's loading. So it's either stuck or it's in the process of doing something. If that happens and you've been waiting for like 5 minutes, you're just going to have to refresh and restart the kernel. To do that, excuse me, you can stop the kernel. Sometimes it might not respond if it's stuck. So you can do this to interrupt what it's doing. And then you have this here, which is going to restart the entire kernel. Keep in mind, when you restart the kernel, it's going to kind of refresh everything. So your code is still going to be there, but things like import, installs, you're going to have to do all over again. So just keep that in mind. And we'll just keep on keeping on just to, so you have all of this knowledge. So I want you to be able to do this. Another quick thing is a shortcut for running the cell. So you can do Shift Enter on your keyboard, and then you see that runs it as well. So just a shortcut in case it's kind of like a big distance from the cell all the way to the run button, whichever you feel most comfortable with. Okay, let's go ahead and dive into these arrays that we've heard so much about. So you have seen this notation before. What does this look similar to? Does this ring a bell to anyone? This kind of data structure. Exactly. Amazing. Yes, looks just like a list. Exactly. And that's why we actually have to tell Python. I love the GIFs as well. That's why we have to tell Python, hey, we are using NumPy to identify this as an array. This is normally, if we just put this in, this is going to be a list. But because we're calling NumPy with this NP and calling the function array, we're building this as an array. You might wonder, okay, what is this extra stuff we have at the end? This is saying within this array, everything we have in here is an integer. That's what we're saying with this. So excellent. You also might wonder, okay, what is the difference between lists and arrays? Arrays are a little bit better for memory. So they're processed a bit better. They take a little less space, meaning it's going to be better for doing a lot of computation. So this is why when it comes to numbers, using arrays, especially if you have big data, is going to be much better and faster. So notice that we can specify these different types with this D type. So this data type. So remember, we can have a float. Remind me of what a float is again. Mini pop quiz. Keep you on your toes. What's a float again? Yes, excellent. So numbers with decimals, those are going to be our floats. Exactly. Even if it looks like an integer, if we call it as a float, you'll notice when we run the cell, you see it already, but when we run the cell, it's going to appear with the decimal. So this would be the 1.0. So the 64 is just kind of our 64-bit. So you don't have to worry too much about the 64. This is more like the notation for Python. So as long as you, one in NumPy, understand that this is going to be an integer, and this is what you need to call this, or to kind of assign this as an integer, that's going to be most important. But the 64 are more going to be kind of referred to the under the hood with Python. So kind of like the memory that we're using for all of these different arrays. Excellent. So with these, we can have all of these different types within our cells. So we can have string, we've seen our string before, and then we have our Boolean, so our true false values. And a great question from Drew, is it mandatory to call the data type? So let's do trial by fire. That's my favorite. So let's see what happens if we don't add the data type. So you see it's still going to be fine, but it's a good way of specifying if you want to make sure your array is of a specific data type. Otherwise, Python is just going to assume based upon what's in your list, or sorry, your array. So, great question. Let's put this back. Awesome. So, and then the 64, this is just kind of our NumPy notation. If we look on our huge NumPy documentation, you'll see kind of different iterations of this like integer and float, and it's going to be kind of how it is stored. It's still going to be an integer and a float, but it's going to change a little bit in how it's stored under the hood. And another great question, can we combine data types in the same array? Yes, in Python, that's actually something that's most powerful with arrays. You can combine different data types in your arrays, but in your lists, it becomes a bit more difficult. So that's another huge thing with arrays, and that's an excellent question. Amazing. I love it. Love the energy here. Oh, I see. So for the U4, so again, it's kind of just another way we're going to identify this as string. So these are kind of just like the under the hood notations that Python's going to use to recognize these different things as string or as everything else. Good questions. Okay, so I know that you unfortunately don't have a Jupyter Notebook quite yet, but assuming the logic that we have here, how would we create this array? So how would we create this array? And I'll give you the numbers as well, just so you don't have to type them. I might not type them correctly myself. These are the numbers for you. How would we create this array in Python? Tell me your thoughts. And I'll give you a minute for this. And I always forget to share my sound, so let me reshare with my sound because let's give you some awaiting music. Amazing. I see so many answers in live chat. Well done. I also see a great question. So let me look for my laser pointer again. So Drew is asking, Drew is asking, I'm not sure if you call the data type since there's an integer and a float. So that's an excellent point. So when you have a mix of these two kind of numeric values, you want to make sure you get the maximum precision. So in this case, we'd want to make sure that this data type is float, just so we don't lose any information. So even though this is still an integer, it would be 50.0, and the zero Python's not going to show. So it would be 50 and then point. So that's still going to be the same number, but with these other numbers, we need to make sure we keep this precision. So that was an excellent question. So as you all have amazingly in live chat, so well done. So let's just talk through this. So first, we have to call NumPy, because remember, if we just assign this to a variable as it is, it's going to be a list, and that's not what we want. We have to use NumPy to make this an array. So first we call NumPy with NP, because remember up here, we told Python that anytime you see NP, that is going to mean NumPy. So first we call NumPy, and we're going to use the array function. So this is going to assign some data that we input as an array. So we want these numbers, we know that much. So we're just going to use our brackets and then type the numbers. And need to make sure I use the correct notation. So just type out the numbers here. And now, after the bracket, we're going to call the data type. So we briefly discussed, or I kind of discussed this at you, but we want this to be a float. So we're going to mark the data type. So D type is going to equal float. So NP dot float. So this is how we're going to assign this as a float value. So amazing. I saw this all in live chat and excellent work. And then I saw a question. Oh, yes. So you're right. I put a comma instead of a dot. Thank you. And now we do this, and then we have our array. Yes, so let's just go over what needs to be imported. So we are just importing the NumPy package, just because this is not a base Python package. So that means when you download Python, NumPy is not automatically included. So we have to import it, and this is assuming you've already downloaded this with pip, but we have to import it so we can use it. So that's what we're importing here. Great clarification. Okay, so now that we know how to build this kind of singular array, we can build multiple arrays and stack them on top of each other. So let's run this cell here. So I'm just running this quickly to do, or like with our shortcut, not really quickly, with Shift Enter. And then you see I get my different arrays. So creating these different arrays here. What we can do is actually put this into a table. I actually saw someone earlier say this kind of looks like Excel. And yes, we're making a table similar to how we made it in Excel. So in this, what we're doing, you notice that this is one array. This here is another array, and this is the third array. So we're stacking these arrays on top of each other to make a table. So when we run this, you see this is what it looks like. It looks like a table or a matrix. And I think you might have seen shape very briefly, but what shape does is it's a function to get the shape or dimensions of the array. So when we run this, you'll notice that we have 3, 3. So 3 by the height and 3 by the width, which is correct because it's a 3 by 3 table. Just to make sure before we go to exercise 2, is everything okay thus far? How are we feeling? Awesome. Great. Love all the thumbs up. Love the good, the quite fine. Okay, I see one like unsure face. If there's anything that I can repeat or clarify, please do let me know because it makes it harder that you actually can't do this yourself. So definitely if there's anything I can repeat or explain again, please do let me know. Yes, great question, Kevin. So in this case, the table is going to be an array of arrays. Exactly. Okay, awesome. All right, so let's continue. So what we're going to do now is we're going to create this array. So just remember the logic that we have here and really look at this notation. So I'm going to actually put this in live chat so you can examine it a bit better. Oops, did the wrong code block. Let me do the full code block so you can see it. So really examine the notation that we're doing here to make this array that you see. So we see it's just an array with numbers from 1, well, it's skipping some numbers, or actually no, 1 through 12. And we're going to make this into an array. So kind of like this table that we're seeing. So I'm going to give you a couple of minutes to do this. And I'm going to give you, yes, another timer. Different music though. So we'll say 2 minutes or maybe 2.5 minutes. Yeah, maybe this makes you go back to your modular arithmetic or solving matrices. I'm gonna get back into the math, maybe. Yes, just turn off my Slack notifications. Sorry. Sorry about that. And my other the analyst is muted, so I totally forgot about it. So let's say maybe another 30 seconds. Or maybe we'll do another full minute. We'll see how many people are still working through. But definitely take your time regardless. And another a great question. So when making a table with multiple data types, does it default to float? So I think this is assuming that you have a mix of float and integer. So usually it will default to the highest precision, but it's better to assign it as float just in case, because you don't want to accidentally lose any precision in your data set. So that's why usually you're going to see a specific data type that we're assigning? That's a great question. Okay, amazing. Let's go over this together. You're knocking this out of the park as usual. So let's go through this. And don't know how that went through. Let me just make sure to double check it muted. I muted everything and then I heard a notification. So let me just double check so you aren't harassed with messages. Okay, I think it unsaved for a second. Okay, so should be good. So now let's go over this. You have this in live chat, but let's just talk through this together. So what you can do, let me draw this out. So this is actually a stack of 3 arrays. So you can think of this kind of split like this. This is one array, and then this is the second in the middle, and then this is the third. So they're kind of stacked on top of each other, just like blocks. So like we saw in the above table, we need to combine these multiple arrays into one big array or into a matrix. So what we'll do is, as many of you, I think pretty much all of you had in live chat, we're going to first begin by assigning our array. So we first just want to make sure we have that outer bracket to make sure this is all included in one big array. And then we can work with our smaller arrays. So it's nice to kind of, when you're in Jupyter Notebook, it's nice to kind of tab down to a different line just to make organization a bit better. So you'll know first we're going to start with this top one here. So we're going to start with this first array that we see, which is just the 1, 2, 3, 4. And keep in mind of these commas. The commas are going to be important. Notice that they're separating all of the numbers, but we also have to separate the arrays with commas. So we're going to put a comma at the end here. Then we start our next array. So then it's 5, 6, 7, 8, comma, begin our next array. And then we have our final one. And then we are all set. So we're assigning this array. And now we see it looks just like this, except we have some commas, of course. And a great question. So can we do columns instead of rows? So with NumPy, just for so you don't have to do kind of complicated things, if you're trying to maybe build by column, you can do this. I can't think of something off the top of my head, but I know there will be, let me actually just mute because it's not saving it keeps undoing my notification request. So there you go. So there's going to definitely be a function in Python to build via columns, but I will say it's pretty uncommon in Python to try to build via your columns first, then your rows. Instead, what would be easier is maybe, depending on what you're using it for, just building tables that are kind of like this. You just get rid of everything like this. So you can build your array something like this and kind of stack them on top of each other like that. You could do that too. So in the world of Python, everything essentially is available. You just have to understand what you need to do your analysis for. So excellent questions. Okay, no problem. Okay. Are we okay with our arrays? And are we okay with the concept of kind of stacking these arrays on top of each other to make a table? Does that make sense? Awesome. Great. If it doesn't, please let me know. Please, please, please. Okay, great. Oh, great question. Do we not need to include the data type here? You could if you wanted to. We still could put the d type int or the np d type. int, I think 64. We could still do this, but since we're using integers here, we're not really worried about precision. So normally you'll see this extra kind of data type specified if we have a lot of decimals or if we have specific data that needs to stay that way. But when we have integers, we're not going to lose anything unless we lose all of the data itself. So here, that's why we're not worrying too much about this, but that is an excellent question. Ooh, great questions, even more. So do we have to name this like the last example? You don't have to, but you could. If you want this to be in a variable, you could say cool table. If you want to. And you'll notice it's not going to print until I say, oops, I did shift enter, until I say cool table. So you could do that, definitely assigning to a variable. And then another great question, are we going to learn how to get rid of these commas? So maybe you see these commas and you're like, I don't like my data organized this way. Yes, you will with pandas. So pandas is excellent for kind of storing data this way and also displaying data in a really effective way. So you'll do that in pandas. Great question. Love it. Okay. So now let's look at creating this array. So just making sure that we're getting the feel of arrays before we work with them in a little bit more complex scenario. Little bit more complex. So keep in mind just the different separation of your different arrays here when we're building the table. And it's a little bit spoiled there, but just try to build this in a couple of minutes. And if you still have questions while we're doing the exercise as well, please let me know and we'll go through them. So with our final kind of brain exercise for arrays, we're working on building this one here. So take a few minutes for that. Oh, and I missed a question as well. So Dong is saying, why didn't we need the print function? That's a great question. So actually, in your terminal and in Jupyter Notebook, if you just call the variable, then it's going to actually print the variable. So print is typically used for debugging. So you'll put your print statement in your huge, huge hundreds of lines of code, maybe. So you can see as you're going through and running the code, you can see where Python is or how far it's executed it. So that's what print statements are really helpful for. But when we kind of want a specific result, then we can just, and of course, assuming it's saved to a variable, we can just call the variable itself. So we don't need a print statement for that. So that's a great question. Amazing. And if you have any other questions, do let me know. Keep them coming. You've had amazing questions so far. Awesome. Answers are coming in. I want to give you a countdown, but I feel like as soon as I tab to YouTube and reshare, the notifications are going to come back somehow. They've been working against me today for some reason. So, and then one thing as well, so it's pretty easy to mistype for this because if you hold shift versus just pressing the bracket button on your keyboard, just make sure when you're doing these arrays that you're using the square bracket rather than the curly bracket. Because remember, you've seen all of those wonderful data types before, especially when we're using dictionaries and everything like that. We need to make sure that our brackets are correct. Excellent work, everyone. Excellent. Okay. Yeah, no worries. No, I wasn't calling you out. I figured it was an accident because it's very easy to do that. But just kind of making sure. Because Python will yell at you for it. Python is ruthless. Okay. Awesome. And then just for Slack, if you're trying to, for example, tab down in Slack without sending the message, you can hold Shift and then hit Enter. And then it will move down a line without sending the message, just in case you're trying to show this in live chat. Awesome. So let's go ahead and build this array now. If you're still working, please do continue working, and let's go over this together. So we notice with the brackets that we have, we kind of see where the separation occurs. So we see that this is going to be 1, like this 1 and the 4, that represents one array. And the 7 and the 10, pardon my comma, I don't know why it looks like that. And the 7 and the 10 are going to represent another array. We also notice that these two arrays are on top. So they're in that first row. Underneath, we see the same or a similar separation. We have the 3 and the 6 are together, better comma. And now we have the 9 and the 12 together. So we have to make sure we understand one, how to stack them, and then two, how to separate them. So let's do this together. So if you want to, you can name this. So even cooler table. And we begin with our function. So we have to call NumPy. We have to tell Python, hey, we're using NumPy and we are calling the array function, which is going to build an array. Now we begin the building. So we already said that this first array here, that is our first one. That's the first one that we're going to build. So we have the 1 and the 4. That's our first one. And now I actually have to add another bracket here because we have a top and a bottom this time. So we even need another bracket just on the outside so we can group these two arrays at the top. So I have the 1 and the 4, and then I'm going to begin to build my next array. Then I have the 7 and the 10. And I have to make sure to close this bracket because remember, this top one is its own kind of bigger array. So the top one needs to be distinguished from the bottom array. So that's why I'm adding this extra bracket here at the end. Now we add the comma again, and I do the same thing with the bottom. So first, my kind of overall bigger array, then my mini array, which is going to be the 3 and the 6. So 3, 6. And then I'm going to have the 9 and the 12. Perfect. So we have that here. And then the reason that we can include this all in the big table that we have is you'll notice here, we still have our big kind of overall brackets. So you see what it looks like. Now we see this here. It's not going to be as, I guess, pretty as we see it here in Codio, but it's going to represent the same thing as we're observing here. And you all doing amazing job as usual. You are crushing these arrays. Well done. I know I'm going to pester you with this again, but does this make sense? Are we feeling okay with this exercise before we move on? I'd rather pester you with it than someone not be or someone be lost and me not know. Awesome. Great. Love the thumbs up. And I love the yeah, good, but a lot of brackets. Yes, I agree. It's kind of a lot of brackets. Ben is like, woo, linear algebra. Yeah, exactly. Just wait, Ben. We've got more coming. Okay, awesome. Please do just shout into the void of live chat. If you're just stuck somewhere, I will see it and I'm happy to re-explain something or go over it again. Okay, now remember in your list, we could use an index to call specific values in order. So just keep in mind, you might have forgotten because it might have been a while since you've used this. Python begins at 0. So the first position is 0. So 0 is our first position. So if we want to call, keep, I scroll down, but then you see it and I'm like, oh, I can't ask my question anymore. But we see that 0 is going to represent the first position. If we call this for table, you see it's going to produce the first array. If I put in a 2 here, what is it going to say? If I put 2 here instead, what's it going to say? Exactly. Amazing, because this first is 0, this second is 1, and this third is 2. So if we want to call this entire third array, then we can index it by its position. Excellent. So same logic with here. Now we can kind of enact all of our hard work from Battleship that we played when we were younger. If we want to specify a particular point, we can give the row and the column. So with this, remember we're saying we want the 0, 1, so something within the second row. And then with this 2, we're going to say the first, the second, and the third column. So there's only one number that matches that, and it's that 22.3. So just keep in mind that we can use arrays similar to lists and using this index to actually specify values. So amazing. Okay. Love it. I love the gifts. Always love the gifts. Okay, so now you all summoned it. This was Ben who did this. No, I'm kidding. So we're gonna go into a little bit of matrix arithmetic here. So don't panic. It won't be too bad, but now we're really going to see the application of NumPy. So let's get into this a bit. So I mentioned earlier about doing calculations with our matrices, and it's not as bad as it seems in doing these calculations. So assume that we have A, which is going to be one of our matrices, and B is going to be the second one. So remember, when we're adding matrices together, you just match them by position. So we would do 1 plus 4, 2 plus 8, 3 plus 16. We're just matching them based upon the position that we're in or that they're in. So that's what you would have right here if you're adding them together. Now, it may seem kind of simple, but it really is efficient in doing these calculations quickly. Because otherwise, if you wanted to do this, you'd have to do a bunch of for loops. So that's not as fun, probably, at least I'm assuming. So we're really saving a lot of time by doing this. So just as we saw here, we're assigning A as this above, as this matrix. We're assigning B as this. And to add them together, It's just like we add any variable together. It's going to be A plus B, and that's going to give us our matrix. Yes, we're going back to all of those mathematics properties that we have. So well done. So given this, and I think you'll figure it out pretty quickly just based on this logic, since we do this to add the matrices together, what are we going to do to subtract them? So how would we subtract these matrices? Amazing. Exactly. So instead of just having plus, we do A minus B. Keep in mind just a little bit of math properties. I think Ben actually said this, I think. So we know that addition, it doesn't matter the order. So A plus B is the same as B plus A, but for subtraction, the order matters. So if we're doing subtraction and we're doing A minus B, then remember we're doing 1 minus 4, we're doing this direction rather than the opposite direction. So if we instead want to do 4 minus 1, we'd have to do B minus A. Now just a quick reminder, and especially when you're working with matrices like these, it's very easy to forget when you're maybe kind of 200 lines deep in Python code. So these are some of the things that you just have to remind yourself about while you're coding. Even though they seem simple, it's good to just kind of logic check or sanity check very quickly. Yeah, so some of them you're going to get negatives, but they're still going to change some of your values. So that's a great point, though. So yes, regardless, we're going to get some negatives, but we do want to make sure that maybe someone has profit that should have profit versus someone at a huge deficit that shouldn't be a deficit. So that's why you just have to cross-check a little bit, but great point. So someone's still going to have a deficit in these matrices, but we want to make sure that the correct person does. And Tia has a great question. So why do we use one bracket here? So it's actually depending on how we're defining the matrix here. So with this matrix, you'll notice that we have the one bracket here and then the one bracket here. So this means we have 1, 2, 3 on top of 10, 20, 30, and that's all together in one array. That's what we're saying. Before, we had a bit more separations. So we were trying to say 1 and 2 are together, but they're separate from 3 and 4. 5 and 6 are together, but they're separate from 7 and 8. So it kind of looks like a similar table, but it's different how we're grouping the data together. It just depends on how you want your data to be grouped. Great question. Okay. And yes, you could get fancy. So if you want to do just difference operations, kind of like our science classes, you have to do a lot of delta anything. You can create a function with this if you just want to do a normal subtraction, just because difference is going to be subtraction. It really depends on what you want to do. You can add an absolute value to the overall result just by kind of encapsulating this with an absolute value. So if you wanted to do that, you'd absolutely could. So it really just depends on what you're looking for in your data calculations. Great questions. Okay, so you already did this one, so well done. So we kind of just went over that. So let's do one more before our break. And don't worry, I'm not going to forget about your break. So we can also multiply these matrices by a scalar. And a scalar, if you kind of remember maybe from physics or from kind of anything in the science and math realm, it's really just going to be a real number. It really means it doesn't have magnitude, but it's just going to be a real number. Or sorry, it doesn't have direction. It's magnitude, but not direction. So if you wanted to multiply just one number by your matrix, it's going to be the same number multiplied to all values in your matrix. Keep that in mind. But if you wanted to do that, maybe you're applying tax to something, maybe you're applying a surcharge, maybe you're figuring out what 20% of someone's total salary would be to take out payment. So something like this, where you need to do the same multiplication on a large group of numbers that you have, then you would use scalar multiplication. And some of you already have this in live chat. Amazing. So can you guess how to do 5 times a in NumPy? So how would we do this in NumPy and multiplying the scalar times our matrix? Amazing. Exactly. So, okay, I did define that. I had to make sure. So, exactly as you mentioned, it would be 5 times A. And when we do this, you see we multiplied every value within the matrix by 5. So, excellent work. Now, I'm just going to introduce you to this before we take our break. But what we're going to do now is go into linear combinations. And I'll explain. This looks like a little bit intimidating, but really it's a weighted sum. And I'll explain more of this after the break. But we're going to utilize this function to play around with some different images in Pillow. So, yeah, algebra jump scare. This is no Five Nights at Freddy's jump scares, though, just algebra. So, you'll see here that we have our pip install pillow, like you saw last time with your importing packages. So, we're going to use pillow and we're going to use this linear combination function to learn more about how to combine images. So let's go ahead then and take our, I think, 10-minute break, and then we'll come back to our algebra. Welcome back, everyone. Okay, have news that you all have access to the Codio case now, which is amazing. So let's just take a moment to open the import, or yes, that's a good point. Let's just take a moment to open the intro to NumPy before we get into everything. And yes, we still are recording as well. So I'm going to go ahead and share my screen. So hopefully now, once you've opened the intro to NumPy case, you see this. If you don't see this immediately while opening it, just make sure to click. There's a link at the very top that says clicking here. When you click that, then it should take you here. So I just want to make sure, let's just take a moment to make sure we're all here before we do our next steps. Okay, awesome. I'm seeing it works. Love to see it. I'm glad you can actually do the exercises with me now. That's awesome. Great. Okay, you see it. So does everyone have this open? Were you able to open the Jupyter notebook? You have this A-okay? Awesome. Okay, I see lots of yeses, lots of thumbs up. Amazing. So just make sure to open this, and we'll actually have to just go to the top. Remember to run your cells. You just first click on the cell that you want to run. You can either click on this run button here, that will run the cell, or you can click Shift Enter just on your keyboard, and that will run the cell as well. Make sure first we have to run this first import NumPy as MP, or else NumPy is not going to work. So just make sure that you've run this and that you see some number here or the number increased if you had a number before. So make sure you do that and you see this increase. And then we're actually good to go with our next part. So this first cell is just going to be the most important for now. Awesome. Love the thumbs up. Once you've done that, we're going to scroll all the way down, or not all the way down, but we're going to scroll through until you see a little bit more, until you see linear combinations. So scroll until you see linear combinations, and that's where we're going to pick up. So I just want to make sure everyone's okay before we continue. Great. All right. So if you're stuck or if something's not working as it should, please do let me know and we'll help catch you up. But let's start again with pillow. You thought you could escape pillow, but no, it's back. It's back and it's here for another case. So remember, by doing this pip install pillow, we're installing the pillow package into our environment. So this is important to run as well, so we can actually utilize pillow. So we're going to shift enter, and you're actually going to see the download. Once you see successfully installed pillow, you're good to go. You shouldn't need to restart your kernel. I think you'll be okay without restarting it. So once you see the successfully installed pillow, you're good to go. So if anything's not working, then please do post in live chat if you see or like a screenshot of the error. That will be amazing. But what we've done just so far, just in case some of you came back a little later from break, what we did was we were running the cell first by you can hit play or on your keyboard shift enter and we scroll all the way down until we see our linear combinations. And then we run this cell to install pillow. Okay, so now, just like we imported NumPy, we also have to import pillow. So in this case, you see we're importing a specific function. So sometimes packages are going to be really, really big, and it's going to take a long time to load the entire package into your environment. In that case, if you're just using maybe one or two functions, then you can just import the specific module. So this time we're just importing image. So make sure to run this cell, hit click, and now we see it's run successfully because the number increased. Now let's look at these beautiful images. So within our Codio environment, in this file path, we have a macaw and we have a tiger, or actually multiple tigers. So using image open, we're taking this file path and this R just means read. So read this file path and we're assigning it to variable A. So A is going to be our macaw and B is going to be our tiger. So doing this, you see, we've now assigned A as our macaw. And then when we run B, I'm just doing shift enter right now in case you don't see me clicking. So shift enter, and now we see our tiger. So we use the image module to assign these images that we had at the specified data path, which could have been your computer as well. It can be a path on your computer if you've installed Jupyter Notebook to your computer. And then we're reading the file and assigning it to this variable. So now images are actually just arrays. So computers are going to process the numbers that actually correspond to the image. So we can actually turn these visual images into arrays. You'll see we do the function, this NumPy function as array. We're going to turn A into array, into some, turn into some as well. We're going to see what's represented with this data. So we see big array. It's pretty huge. Recording. Okay, there we go. Thanks. So, and yes, so these are going to represent the different pixels. Exactly. Amazing. Yes, these are RGB values. So you notice that in kind of our groups, it's always groups of three. So we have these stacked arrays of three. So this first one is R, so red. The second one represents green, and this last one is blue. In this case, we have 250 of them, so it's 250 by 250 because that's the size of the image. So when we actually look at the shape, we see the height is going to be 250, the width is going to be 250, and within each of those arrays, we're going to have three elements for RGB. So excellent, excellent work. Now, let's create a function. So the functions have come back to haunt us. I'm apologizing in advance, but I'll give you kind of the structure of the function just to make it a little bit easier. But first, let's talk through what's happening. And if you're already like, I've got functions in the bag, I do this just when I sleep, then feel free to go on to exercise 6. Otherwise, we're just going to explain this a little bit. So what we're going to do is we're going to create a function where the input, or it's going to take two matrices and one scalar as arguments. Remember, you have to define the parameters of your function. So you have to tell it, what do you need to enter into this function for it to work? So that is going to be two matrices and one scalar as the arguments. And the output needs to be the linear combination of these matrices. And you're going to call this function linear combination. Just as a reminder, let's look at that function or that formula again. So we need to essentially do just this. So we need to do this, and we know alpha is our scalar. So alpha is going to be our scalar. A is one of our matrices, and B is going to be the second matrix. So we're essentially turning this into a function. We're turning this application of the equation into a function. And I don't think I'm not sure how this is going to look when I copy it. Oh, it's actually fine. Okay. Just so you can see it, okay, I'll put it here. So you can have this. Oop. Didn't like me doing that. It froze for a second. Okay. So, and now just a reminder for your functions. So remember, when we have our functions, we need to start them with def, space, insert your favorite function name here, parentheses, your parameters. So remember, that is how you begin your function. So I'll also go ahead and put that in live chat. So we start with def, and then we're going to begin with our function name. So I'll do insert function name here. And then you have your parameters. So parameter 1, parameter 2, parameter 3. I might have spelled parameter wrong. Parameter 3. So then you have your different parameters, just as a reminder for defining these functions. If you want to be fancy and include your doc strings so people know what your function is, you absolutely can. If you're just like, I don't want to see doc strings for a bit, that's okay too. So we know with this function, we have to include that linear combination that we just reviewed. In addition, so NumPy it's a little bit picky. You're going to need to convert your data type. So we need to convert it to this integer using this specific kind of code. So is the video okay? Can you see me? I saw someone ask if the video was frozen. Working now? Oh, okay. Okay, cool. So, okay, great. Awesome. I just want to make sure. Thank you for confirming. I appreciate it. So, just one thing that we have to do because NumPy is a little bit particular. After you've defined your linear combination equation, you also have to include this. So after you've defined that equation, just make sure your next line is going to include this. So you have to convert your array. So A is just an array name. It can be any array name that you want, but you have to convert your array to this integer type. So just make sure to do that. Okay. So let's try our best with this function. I know we haven't seen functions overall too much, but try your best with this and I can, let me see. I'm going to try the music again. I think I've muted it properly. Actually, I'm sorry, I'm not going to risk it. I just don't want you to be pinged with Slack messages potentially. So let's just try this function for now. So try to build this function with exercise 6. If you're stuck, then please let me know. I can kind of give you some extra hints to help you build that structure. So try your best with exercise 6, and then afterwards we will review it together. Amazing. Amazing work. Great question. So how do you get the alpha symbol as an argument? So we're not going to actually use alpha. So instead, what you can do, you can just type alpha. So that will be fine too. And yes, so alpha is going to be that same alpha that we see here. Exactly. So technically, it can be any real number, but it gets kind of weird when it's not between 0 and 1, but it technically can be any real number. Great question. Amazing. Amazing work, everyone. We'll give it maybe one more minute and then we'll review because I see the lovely several people are typing. So I want to give you enough time to really try this. And amazing, we've got the doc strings too. Well done. Doc strings are really helpful because when you make a function now and then 2 months pass and you're like, I have no idea what this does. Very, very helpful. So more useful than you think. Well done. Well done. So a few more seconds and then we'll go over it together. Yes, the 0, 1 alpha makes it so that it's actually properly combined. I do agree. Um, yes, I think it is better to define it like that if you actually want to combine the images without weird things happening. So yes, that restriction definitely would be valid. Great point. Awesome. Okay, let's go over this together. You all are just cruising through NumPy. You just wait until you see pandas. Pandas is amazing. I can't give enough love to pandas, the animal and the package. So we said this before, but we have to start with def. So we're defining our function first. So it's telling us here to call this linear combination. So that's just what I'm going to call it. I'm going to try to spell it right. Linear combination. It's actually telling us our arguments here as well. We have our two matrices. Our first matrix is A. Our second one is B. And then we have our scalar argument, which if you go back to the formula, that's just alpha. So my argument, A, my first matrix, B, my second matrix, and then alpha, which is our scalar. Don't forget that colon. The colon is so easy to forget, so don't forget it. You see how lovely Jupyter Notebook is, and it did this indentation for me. So Jupyter Notebook MVP. So if you want, you could have your doc strings. So it's helping me a little too much. So let me, sometimes it's doing that. So we have our doc strings. If we really wanted to do this, it's good practice. And we can say linear combination of A and B according to formula. And if you're really good, then you put in the formula. And you also can give your restrictions if you want alpha to be inclusive between 0 and 1. You can say that. So maybe we say alpha must be 0, 1. Oops. You can say that. Or you can just say alpha is scalar. Up to you what you put in here. So then we close our docstring, and then we begin the actual building of the formula. So I'm going to assign this to a variable. So like you all saw, we're assigning this to LC. This variable can be called anything as long as you're consistent with it. So you just have to make sure you're using the same variable name. So we're just using the formula that I actually pasted in live chat before. So the formula it was alpha times the first matrix plus, and we have that, oops, I need my parentheses. We have our parentheses 1 minus alpha times B. I feel like this looks really weird at first. This looks really complex, but this is actually a weighted sum. So this is saying, do you want more representation of A, or do you want more representation of B? Because you'll see, I won't say too much because I don't want to spoil it. So this alpha is going to depend, or it's going to weigh how much of one matrix you see more than the other. So this is why it's going to be a weighted sum. And without me saying too much, you'll see how this happens visually. Then we have to use our little tip here. So it's saying, okay, you have your array, but you need to convert it to this unit type here. So we'll do just that. So LC equals, just making sure I spell it correct. So the data type is going to be uint. So now we're just doing this conversion. This is just because Pillow wants our integers within this specific format. So we just have to make Pillow happy. And then we have to, of course, return our linearly combined matrix. So we'll do return LC. When you run this, nothing should happen unless there's an error. And that's fine because you need this to just be defined. We're just defining our function. We're actually not applying it yet. So so you'll see, Jennifer, that syntax error. So I don't see all of your function there. So just make sure you have this entire kind of chunk that you see here, and then you run your cell. Because if you just put just this first line, that's not a complete function. So Python will be confused. So it's saying you haven't really defined your function. You've started, but you haven't completed anything. So that's why it's giving you that error. And so the uint is actually just we're defining just as the integer. So unit, it is confusing. It looks very similar to unit, but we're saying use this as an integer with this kind of sorting type. So yeah, good question. Yeah, no, that's a great question. Okay. So we kind of like upped it a little bit with our function. Are we okay with this function? Any other questions with this? Or any other errors that you're seeing too when you do this? Your silence scares me. Silence is it's not usually good. Good. Okay. Hank's okay. Okay. Grace is like, I am over it now. I'm done. I don't like Python. I get it. Awesome. Okay. So if I can repeat anything, please do let me know. If any of the parts are unclear, happy to go over it again. Okay. Just make sure more of us are okay before we continue. Hanging in there. Awesome. Well done. So yes, it's just kind of how we're storing it. So the type we're storing it as. So we have 8 here. Before we had 64. So it's just how many kind of levels of the integers are we storing. So just kind of pillow kind of semantics, essentially. Good questions. And yeah, it's an 8, sorry. Okay. So now we can actually use our function and actually see what it does. So we're going to call our function. We called this linear combination. Remember before we already created our A array and our B array, and we can give it a scalar. We'll stick with between 0 and 1 right now. You can test it if you go beyond 1 or less than 0. You can see what happens. It's interesting. But for now, we'll stick between 0 and 1. And we're going to assign this linear combination to this lin AB array. Now, while it's very cool to see that our function worked, the numbers don't mean much to us ourselves. I don't know kind of RGB just by heart. I don't know what the colors mean by heart. So let's visualize these results. So we can use our image module to visualize this linear transformation. And for the moment of truth, we have a weird macaw tiger. So we have the linear combination of our two images. It's actually going to be this perfect combination because by using 0.5, we're getting half of our A matrix or our A image and half of our B. So we get this perfect merge. If you're getting A array not defined, then make sure just go all the way here and run this cell again. So just run the cell again and then it should work for you. But yes, it is interesting. So now go ahead and take some time. I think this is the more fun part. Take some time to explore these different linear combinations. See what happens with 0, see what happens with 1, or even you don't have to restrict yourself to these numbers. Pick some other numbers if you like. So I'll give you a few minutes just to try these different alpha values and feel free to try more as well to see what happens. And so I see your syntax. Jennifer, I think you used a 1 instead of an L accidentally. So that's why Python's mad. So just make sure to change that green 1 to an L and then you'll be all good. Yeah, no, they look very similar, so I definitely see. Yes, we're doing Photoshop, but make it Python. So ultimate Photoshop here. Awesome. Glad it's working, Hank. Amazing. So I see some errors. Happy to debug while you're kind of testing your beautiful new function. So, okay, if NP is not defined, then you just have to go all the way back up and then run this cell here. So just run this first cell again, and then you'll be good. Let me go back till I see the McKiger. And so then, Donta, with your linear function, make sure you don't want to actually put the scalar in your function. You want to put alpha in the function. So then you can use it for any different type of scalar value. So every time you see that 0.5, change that to alpha, and then it should be okay. I see some beautiful McKeigers. What happens? What about if we have 0? What does 0 do? Or what does 1 do? Yes, 0 equals tiger. So let's go through some of these. So with the debugs, I think your amazing TAs are on the case. Most of the time, I think it's because something's not defined. So just try running your cells again. And especially if you restarted the kernel, you need to import NumPy again and then import pillow again. So just make sure to run all the cells. So one thing I just want to tell you quickly, instead of having to manually run all your cells individually, you can press this button and this will restart the kernel and then rerun all of your cells just all at once, just in case you need to do both. Okay, so let's use this. So let's use this and we're going to see what happens with our different values of alpha. So I'm going to kind of just use, well, we'll go over again. So for our first one, we want 0. So image, and with our linear combination function, I almost typed function, we want our A array, our B array, and we'll try 0 first and see what happens. And as you all mentioned, this is our tiger. And if we go back to the function, this is actually why I was saying these are our weighted sums. If alpha equals 0, it completely gets rid of matrix A because 0 times A is going to be 0. So that only leaves you with B, which is the tiger. Similarly, when we multiply by 1, 1 minus 1 in the middle is going to be 0. So it's going to get rid of the tiger. So this is why it's a weighted average. We have on our extreme, so on 0 is going to be tiger, and then 1 is going to be macaw. So within, you're telling Python with this equation, how much macaw do you want versus how much tiger do you want? So that's what we're doing. Okay. So let's just look at all of these examples. So we did 0. Let's look at 1. So now, kind of with that logic, you see that we have all macaw. I think the more interesting ones are when we have this mix. So let's look at the 0.25. And now you see we have more tiger than macaw. And that's because we're kind of like in a timeline or like on a scale. 0, we saw the 0 scale is tiger, 1 is macaw. So the closer we are to 0, the more tiger. The closer we are to 1, the more macaw. So that's what this function is doing. And we'll hammer that logic home with this 0.75. And now we get more macaw than tiger. So, yes, you see how they make those flying tigers. You see how they make those fade outs with this combinations, with these linear combinations. So, amazing. Let's go over some slices now. So we'll review some slices just because it's important to understand this logic here. So, yeah, can I go back to line 40? I don't know which line that is, but which line do you need? Hopefully I've shown you it somewhere. Okay, so all these also are going to be in polls and answers too, just in case you missed anything. So let's go ahead and look at these different slices. So this notation is important to understand if we want to include specific data. So if we want to kind of cut out some of our arrays, but include numbers within other parts of the array. So this first part before the comma, to the left of the comma, this is vertical. This is representing our height. This next one here, this is representing horizontal. So remember, in this array format, it's going to go height first, and then we have width. So just make sure to keep that in mind. So what we're saying here is only keep 50 through 100. Only keep arrays 50 through 100. That's what we're saying for the vertical aspect, but for the horizontal aspect, which comes after the comma, we're saying keep everything. So when you see a colon here, that's telling you keep everything. So keep that in mind as well. I know we're throwing a lot of new things at you. I apologize, but hopefully this notation makes sense. So let's see what happens. We've only included a specific amount of things vertically. So we've kind of cut off our array vertically, but we've included everything horizontally. So we expect to see a sliced image vertically, meaning it's not going to include the entire height of the image. And when we run this, we see just that. So we have the full width of this, but you see the height is cut off. And Drew asked a great question. Will we be dealing with code like this a lot? With arrays and kind of slicing arrays, absolutely. Maybe not as much with images. Personally, when I do data analysis, I don't kind of work with images too often. But slicing arrays and including specific portions of arrays and excluding others, absolutely. So that's a great question. So I know you see it here, but can you talk me through what is happening here? Can you remind me first, what does this colon mean in this position? By putting this colon to the left of the comma, what does that mean? Amazing. Exactly. Well done. So yes, this is saying keep everything in the vertical. Keep the entire height. Excellent work. But now we're restricting the width. So we're going to slice horizontally now. We're not going to get the entire width, but instead we'll have the entire height. So now what we do is it's going to be just like this. So not the best kind of cropping, but that's what we're doing. We're cropping the image. So here, this is actually a completely different notation I feel like this might be a little confusing when you're starting, so I would recommend using the notation here rather than here. When you see this on its own, this is taking a copy of the image. So it's taking a copy of the array in this case. So you might think, oh, we have this colon here, so maybe we're keeping all of the vertical, and maybe this is a horizontal slice. The logic is there, but that's not what we're doing. This is saying, take a copy of your array, and then this is saying, only keep some of your vertical portion of your array. So this is only a copy. This is still the vertical that we're doing. So this still corresponds to vertical. So that's a little bit confusing, but just remember when this is on its own, it's like you're taking a copy of the array, and anything that comes after is still going to be first. So it still corresponds with vertical. So this is still vertical. If instead we wanted to also slice horizontal, we could do that too. And maybe I want to just do that again. Then, okay, yeah, it did it, but it's not showing because it's mad at me. But we're slicing again because I went out of bounds of the image. But you can slice it again by adding this extra step. But I feel that this is going to be a bit too complex. So I think using this notation is going to be better. And yeah, why would you need to copy an array? So you'll see this a bit more with data frames. So sometimes we have this copy because we want to filter out a specific portion of the data, or we want to exclude a specific portion. So if we want to copy it and then assign it to a different variable, we use this notation to kind of more quickly do this filtering or more quickly do this cropping. So it's really just an added notation. I wouldn't really like properly call it a copy. This is just notation that you can use to also crop or exclude or filter your data. I think it really is more prominent in pandas. I see it a lot more with pandas. When you're filtering your data frame, you have to do this too. You have to make the copy of the data frame and then apply your filter to it. So it's just getting you used to the format. So, great question. Okay. So another great point. So if you don't see the image by kind of just printing out that array, what is showing the image is this from array. So this from array function is taking the array and converting it to an image. So if you just print out the array by itself, it's going to give you numbers, but it's this function from array that's actually printing out that image. So just to clarify. No problem. Yeah, we've got the pretty images of birds and tigers, so I totally understand. So let's do this final exercise, and I'll just tell you a little bit about RGB towards the end, but it's not crucial. But if you have time, you can review it again. Now that we've gone through cropping, how would you slice the tiger photo to crop it to 200 pixels? So I'm just going to give you, while you're doing this, feel free to start, but I want to give you a poorly drawn diagram. And I can't draw squares. I can't draw at all. But keep in mind that if we're going by width, we can start 0. And then this would be 250. I got scared. Slack just restarted by its own. And then it startled me. So then this is 250. So looking at width. So if I wanted to crop, meaning I want to kind of take off 25 pixels from the end, instead of starting at 0, I have to start a little bit more in. I have to start further in. And instead of starting at 250, I have to subtract however many pixels I want to go in by. So this is my difference. This is how many pixels I want to subtract. And so you can read it. I'm going to type that part. How many pixels to subtract? And awesome. So I see some of you have it, but just wanted to explain that a little bit better. So that means on all of our axes, not just on width, but also on height, we have to remove those 25 pixels. So instead of having, I think actually it was 250 before, but we're removing 25 pixels so we can crop our image to this smaller version. Amazing. So just for the sake of time, if you're still working, please keep working. But I just want to go through this for the sake of time. Ooh, let me get rid of that. Okay, so a lot of you have this in live chat as well, so excellent and well done. So if I wanted to crop this, so first we're going to do our image from array because no, from array. And we're going to do this so it actually displays the cropped image. So what we'll do is, remember the tiger is B. So B array, we're going to take 25. So we're going 25 in. So 25 in. And then we have to also subtract that 25 on the other end. So 225. And then the same thing with our height. So whoops, sorry. Forgot to make my actual array. So we're doing 25 in. So 25 to 225. And then the same thing for our width. So we have to do the exact same thing. 225. Make sure it's not 255, but actually 225. So we're just taking 25 off from each kind of section of our array. And when we run this, it's hard to tell. Maybe it's better if you compare the two images, if you have them side by side. Then we can see that our tiger image is a little bit smaller. So now you actually know how cropping happens. We're excluding some of the array that has to do with our pixels. So we're taking out and not including some of those pixels in this final array. So, excellent. Any questions before I just briefly tell you a little bit about this random noise? I feel like some of you are like, okay, it's been a lot of Python today. I'm ready to, give my brain a break, eat some ice cream, relax, watch some TV. I totally get it. We're almost done. And yes, absolutely. So great point, Dante. You can get the same thing with variations. So instead of going the forward direction, you can go kind of opposite by using negative values or using minus symbol. So great observation, Dante. Okay, lunch is calling my name. I know, I totally understand. 3 more minutes. So for the sake of time, I'm just going to explain this to you. This is very similar to what we've done before, but not really any new concepts, but more reapplication of concepts. So with this, what you can do is we can take our array. So we can take everything from the height, everything from the width, and we can only select this time the, remember, RGB value. So which value would this be? If we know that this third channel has to do with RGB, which one is this? And Dante, I'm jealous. You already had ice cream. No fair. I love ice cream. Yes, and a lot of you already kind of know what's going to happen. Exactly. This has to do with red. This is our red channel. So, excellent. We can do some different functions to add noise to our channel. So if we run this function, what we can do is we still have our 250 by 250 image with all of our three color channels. And what we'll do is add some random noise and multiply it by the scalar to really make the noise more prominent. So then afterwards, we're going to add our noisy matrix with our normal matrix. And we're going to put them together and see what happens when we have our noise. So we're adding this noise to our normal matrix to give it that kind of, I guess, grainy effect that I don't even remember the different filters. But I'll quickly just show you this. So I'm just going to kind of take this for the sake of time and show you this and explain it. So we have our array, we have our matrix, and we have our scalar to tell you how much noise do you want to see. We're going to give it a random matrix with just some random numbers. And remember, these are random pixels of different colors. And we're going to multiply that random matrix by a scalar to make it even crazier. And that's going to give us our noisy matrix. And once we do that, we get some grainy macaw. So we get a bit of a grainy macaw. If we increase this, so if we add more noise and make that noise bigger, even grainier. So all of the noise here. So there's a little bit at the end with just kind of defining different color types. Definitely go through that just to make sure you've got your array understanding down and how to slice and kind of compact your arrays. But otherwise, excellent work today with our macaws and our tigers and our first introduction with NumPy. And I loved your energy today. It was amazing being here and seeing your lovely faces. And I hope you have a wonderful rest of your week, everyone. Bye.
Thank you so much. Bye, everyone. Have a great day.